We want to determine a piecewise smooth curve for the curve shown below, where if the curve is the curve C, it's equal to curve C sub 1 plus curve C sub 2 plus curve C sub 3. So to make the curve C piecewise smooth, we'll write parametric equations for these three curves. Looking at the orientation, we'll first go from the point 0, 0 to the point 2, 5 along this segment. Notice how the x-coordinate increases from 0 to 2, and the y-coordinate increases from 0 to 5. So one way to parameterize curve 1, or curve C sub 1, would be to let x, or x of t, be equal to 0 plus 2 times t, and let y of t be equal to 0 plus 5t, where t would be on the closed interval from 0 to 1. Of course, we can simplify x of t to just 2t, and y of t to just 5t. But the reason I included the 0 here, because notice how these were the starting coordinates of this point here, 0, 0. Now let's focus on curve C sub 2, which goes from the point 2, 5 to the point 5, 2 along this segment here. So notice how the x-coordinate starts at 2 and increases by 3 to a value of 5, and the y-coordinate starts at a value of 5 and decreases by 3 to a value of 2. Which means for curve C sub 2, we can let x, or x of t, be equal to 2 plus, now the x-coordinate increases by 3, so we might be thinking it should be plus 3t, but that would only be true if t was on the interval from 0 to 1, but now t is going to be on the interval from 1 to 2, which means it's not going to be 3 times t, it's going to be 3 times the quantity t minus 1. And then for y of t, we would have 5, and the y-coordinate decreases by 3, so we'll have minus 3, but then not times t, we'll have times the quantity t minus 1. And of course, we can simplify here. If we distribute, we'd have 2 plus 3t minus 3, which would be 3t minus 1. And here we'd have 5 minus 3t plus 3, which would be 8 minus 3t. Notice how if we substitute 1 in for t, the x value would be 2, and the y value would be 5, which would give us the point 2, 5. And when t is 2, x is 6 minus 1, or 5, and y is equal to 8 minus 6, which does equal 2. And then finally for c sub 3, we want to go from the point 5, 2 to the point 0, 0 along this segment. So the x-coordinate starts at 5 and decreases by 5 to 0, and the y-coordinate starts at 2 and decreases by 2 back to a value of 0. So x, or x of t, is going to be equal to 5 minus 5 times not t, because now t is going to be on the closed interval from 2 to 3, so it's going to be 5 times the quantity t minus 2. And for y of t, the y-coordinate starts at 2, so we'll have 2, and it decreases by 2 back to 0, so we'll have minus 2 times the quantity t minus 2. Of course, we can go ahead and simplify. Here we have 5 minus 5t plus 10, which would be 15 minus 5t. And here we'd have 2 minus 2t plus 4, which will give us 6 minus 2t. So here we have the parametric equations that make the curve C piecewise smooth. We could also write this piecewise smooth curve as a vectored valued function, where we'd have r of t is equal to, for curve C sub 1, the s component would be 2t, the y component would be 5t. This would be when t is on the closed interval from 0 to 1. For curve C sub 2, we'd have an x component of 3t minus 1, a y component of 8 minus 3t. This is when t is on the closed interval from 1 to 2. And finally, for curve C sub 3, the s component would be 15 minus 5t, and the y component would be 6 minus 2t. And t would be on the closed interval from 2 to 3. I hope you found this helpful.